The animate method that we used in the previous video is not only good for fades, but we can use pretty much any type of animation with it. So in this video, we're going to just look at a few different types, and we're going to start with translations. So I'm going to just comment out the lines to do with Homer. We haven't actually seen comments officially before, but they're very useful ways to annotate your code to show what your code is doing, and they're also quite useful for getting rid of lines of code that you don't necessarily want to delete because you might want to use them later, but you're not interested in them right now. And to create a comment, we just use a double slash like that, which is the same as pretty much every programming language out there, and that comments out the line following the double slash. So let's say we wanted to move Bart off the screen. So from his initial central position, just drop him off the screen using an animation. Well, obviously we don't want to fade him out anymore, so we'll remove the alpha. And then if you put a Y here, you can see we've got a bunch of different transformations that we can use on Y. Now, Y is the vertical axis, so from top to bottom of the screen. And what we're particularly interested in here is translation Y by. So translation, if you may remember from your math studies, is a movement essentially. So we're just moving it around the screen. And then if we want to move it by a certain number of pixels, then we put those number of pixels in. So if we want to move it off the screen, probably something like 1,000 pixels is going to do a good job. Now, as I said before, we should clarify that this is a float, even though it looks a bit like an integer. So we'll just put an F on the end, just to be very clear that this is a float. So now, instead of fading Bart out, this is going to translate him down the screen, which will essentially just move him off the bottom of the screen. Let's take a look. So there he is, give him a tap, and off he goes. So 2 seconds off the bottom of the screen. Fabulous. So very quick challenge for you. Can you make it so that instead of translating off the bottom of the screen, he translates off the left of the screen? So off to the left, not at the bottom. Good luck. Did you manage that? There were two aspects to it. One of them was the fairly straightforward. Instead of translation Y by, we changed the method name to translation X by. Get rid of those other bits we don't need. But you may have anticipated, or you may have realized when you run your app, that this is going to move it off to the right, and I asked to move off to the left. So we just changed that to a minus, and then a minus moves it to the left or up if you're doing a vertical translation. So let's just check, make sure that works. That should animate Bart off to the left of the screen this time. Here we go. So there he is, and tap on him, and off he goes to the left. Brilliant. So that's translations, moving left, right, up, and down. Another useful thing to do with translations is move an object onto the screen when it's initially off the screen. So maybe you want to have an object that slides in from the left or from the top or something like that. The way I would do that would be to initially take your object and move it off screen. So we could do that using an animation. Remember, our onCreate method down here is what happens when the app itself is actually run. So if I copy that down and copy the image view setup as well. So if I ran this code, we'd find that as soon as the app was run, Bart would be animated off the screen with this duration. However, that's not really exactly what we want. We don't want an animation to put him off the screen. We want him to be invisible to the user at the very start. So what we can do is, instead of animating, we just use set translation X, and that is basically the same as an animation but with a 0 animation time, so it happens instantly rather than gradually. So if we want to set him off the screen to the left, we might use minus 1000 and then the F to clarify that this is a float. And then of course we want to change the animation so that it's 1000 F, moving back to the right and onto the screen. One issue with the app as we've got at the moment is that it's not actually going to work because we can't tap on Bart when he's off the screen. So what I'm going to do is just bring in Homer just a little bit to allow us to tap on him. So we'll change the, where are we, the alpha to 0.2 just so that we can see him. There he is, just about. And then we'll change the on click to, what was that? Fade was the name of our method. So now we can click on either Bart or Homer. And this time when we run the app, Bart will not be there. Even though he's there in our design view, our app will be initially empty. Oh no, it won't be empty, sorry. It will have faded Homer in there. So we'll be able to see just faded Homer, but not Bart. So there we go. And then if we tap on Homer, then Bart animates in. Fabulous. Of course, you don't need a faded Homer to get the animation in. You could have a button or just have it happen automatically, however you want to trigger the animation. But that's how you animate something in from off the edge of the screen. Let's look at some different types of animation. So let's take rotations, for example. Now, I want to get rid of this taking Bart off the screen. I'm just going to show you another type of comment. While I do that, we can comment blocks of code using slash and then star, and then end our comment using star and then slash. So again, very standard. Almost all programming languages use something very similar to that, and that just allows you to block off the whole of the code in between those two lines rather than doing it line by line. Okay, so let's try a rotation. So again, we can just change that and rotation there. So there it is. And then all we need to put in the parentheses is the angle that we want to rotate. So this is in degrees. So 360 would be a full rotation. So let's try 180 degrees. And we'll put an F on again because this is a float. So this should be a rotation that turns him upside down because we're rotating half of a full circle in 2 seconds. Let's take a look. In fact, just while that's loading, I'll get rid of Homer for our future apps because we don't need him now that Bart's on the screen. Let's take a look. So there we go. Lovely. Just as you'd want a nice rotation. You can experiment with that. If you up the number of degrees substantially, then you can get him kind of spinning around. Let's have a quick look at that. It's quite good fun. So that'll be a lot of circles in 2 seconds. And we shouldn't have Homer anymore. Visible at least. Here we go. Hey, good fun. All right, lovely. So there's our rotations. The last type of transformation that we're going to look at is shrinking and growing, so making something bigger and smaller. We do that using scale. So we've got scale X and scale Y. So let's say we want to shrink him down to half his size. So we'll go for scale X to 0.5 and again F. And we're going to want to scale Y as well. So let's put that in, scale Y and 0.5 F. And this also shows you how you can combine a number of different transformations very easily. So we could put an alpha in there to change the opacity. We could put a rotational value, and we could put whatever we like in, and you can combine all those into just a single transformation. So let's just have a quick look at that. We should find that Bart animates. You might want to think about what happens to Bart's position. Is he going to remain in the center of the screen? Is he going to move off to one corner? See if you can anticipate what he's going to do. Here we go. He does indeed remain at the center. so the center point of the image is maintained. So that's all the transformations we're going to look at. I'm going to give you a very simple challenge to practice these, and that simply is to create an animation using 3 of the different transformation types that we've seen, which results in Bart ending up full screen and positioned as he was initially. So you can be as creative as you like, go for whatever type of transformations you want, but it has to be at least 3, and Bart has to end up in his original position. Go for it. All right, hope you had fun with that one. So I'm going to start off by bringing back my code to move Bart around at the beginning, and I'm going to give him 2 translations to start with. So a translation of X, so off to the left of the screen, and that's off to the top of the screen as well. And then I'm going to bring him in and spin him at the same time. So let's get rid of those. So my 2 translations are going to be, if I just put translation X by, and I want 1000 F there, and translation Y by, and 1000 F there too. And finally, I want to do the spin, so that's rotation by, and then we'll do 3600 degrees, which will see him rotating 10 times in that 2 seconds. Now you can see it's not that easy to see what's going on here when you've got these really long lines. So it's possible to break them into several different lines just by adding line breaks. And that just makes the code look a lot nicer when you've got these long lines with lots of different methods in there. So I'd recommend doing that to keep your code nice and readable. Now, of course, as Bart is off screen, we're going to need Homer again to have something to tap on. So I'll give him his alpha of 0.2, just so he's there for us to make Bart do his spinning and moving. Great, so let's have a look. That should do what we want. So when it runs, we should just see Homer because Bart's been moved off screen. And then when we tap Homer, Bart should come spinning into view. Here we go. There he comes. Fabulous. Fantastic. So I hope you managed to come up with something even more exciting than my transformation there. We're now going to use our considerable animation skills to make a really quite complicated app, a game version of Connect 4. Which if you haven't played before, I'll explain the rules in the next one, and we're going to make it on our phone screen. See you there.